Hello everyone. Today we are going to learn 6.2 binomial distribution. So when we hear about binomial, what can we think about that? Bi is two, right? So two. All right. So we have objective here. And let's talk about um, what is binomial, right? So we have a discrete random variable from the previous section, right? So they say that there are theoretical formulas that allow us to find probability without using empirical method or complicated analysis. So binomial random variable is one such a example. All right. Okay. Now we have a criterion of binomial experiment here. So they say that Bernoulli trial here. So number one, there are fixed number of trial. And so, and we had earlier sample size, right? So here we say the fixed number trial, n equal to 10, n equal to 20, n equal to 30, right? And number two, there are two possible outcomes in each trial called success and failure. So we had a binomial random variable, right? Binomial experiment. This is come from success or failure. Those are bi. That's what the name is, binomial. Okay, success or failure. So this is by, yeah. This one is by success or failure, okay? All right, so the probability of a successful outcome is the same for each trial. And number four, the trial are independent. What was the independent? The outcome of event A does not affect outcome of B, right? Yeah. So outcome of event A does not affect outcome of B, right? Event V. Yeah. So we have to make satisfied all the trials in order to be binomial experiment, right? Okay. We have this example. Let's take a look whether they are binomial experiment or not. All right. Okay. So here, the first one, X is the number of tails in 10 coin flips. Okay. All right. So let's check that. Let me bring that criteria. Oh, I make annotating. So hold on one second. Okay. All right. So I brought definition here so that we can take a look. So first one, X is the number of tails in 10 coin flips, right? All right. So the first one, let's check that n equal to 10. Yeah, 10 flips, right? So that is a fixed trial. Make sense? Okay. Second one, there are two possible outcomes, success or failure. Okay. So getting tail will be success in that case. And what other outcome will be? Getting head will be failure. Make sense? Okay. Then number 3, the probability of a successful outcome. So in that case, getting tail, what's the probability of getting tail? We know 0.5, which is 50%, right? For each flip the coin, right? All right. Now, trial are independent, is it? Yes, because the first outcome, whether we get the tail or head, the outcome does not affect the second outcome, right? Or second outcome does not affect the third one, right? Yeah, so number 4, it's independent. So everything satisfied, Bernoulli trial. Okay, so we say that this is a binomial, right? So let's denote the x is the number of trial in 10 coin flips satisfied. Let me just satisfied, and it is binomial random variable. X is binomial random variable. X is binomial random variable, right? Okay, let's take a look. Second one. All right, second one say that X is the sum of face of 2 6-sided dice that are rolled. Okay, then let's check that. Fix the trial first. N equal to how much? We don't have that, right? There is no fixed trial because they don't say that, right? Unlike A, right? So no fixed trial. So X is not binomial random variable. So we don't have to check others. Even though, oh, you didn't see that. Even though other one is satisfied, this one did not satisfied. So waste of time, check the others. All right. All right, so let's take a look. Hold on 1 second, let me arrange a little bit. Here we go. See, so let's take a look. See, like a cat. So X is number of twos that show up on 3 rolled 6-sided dice. Yeah. Okay. So in that case, what's the n? N equal to 3. Yeah. Fix the trial. Number 2, success or failure. So getting 2, right? 2 is two. Success Not two. Failure, right? Okay. Number three. What's the probability of getting two? It's a 1 out of 6. Yeah. So 1, 2 there, and then the sample size is a 6. Number 4. I don't have to write down, right? We knew? Yeah. So number 2 over number of sample space, sample size, same thing. All right. Number 4. Trial all are independent, yes. So the first outcome does not affect the second outcome. Second outcome does not affect the third outcome, and so on, right? So it's independent. Then we can say the X is binomial random variable. All right. Okay, so let us do next one. X is the number of chocolate donuts out of 2 randomly selected donuts from a box containing 3 chocolate, 4 maple, 3 plain, and 2 sprinkled donuts, right? Okay, so uh, what's the what is called the fixed trial? Fixed trial. Just 2? Okay, number 2. What's the success? Chocolate, getting chocolate is success, right? Chocolate. Success. No chocolate, failure, right? Failure. Okay. Number 3, probability. So what's the, we getting probability chocolate? So, how many total? So 3, 4, 7, 10, 12, right? Total is 12. How many chocolate? It's a 3 out of 12, right? Okay, so let's do that. Independent first, then we talk about the probability, right? So number 4, are they independent? Think. Okay, so this is not independent. Not independent. Why? Because if we getting chocolate the first time, then second choice less likely getting probability of chocolate, right? If we didn't have chocolate at first time, then second choice, second probability, there are more likely getting chocolate. Make sense? So first outcome affect second outcome because we have only 2 choice, n equal to 2 trial. Is it clear to you? Let me write down. Okay, so I wrote down this one here. So not the independent since the outcome of first trial affects the outcome of second trial or vice versa, right? All right, then let's talk about the probability. So what's the probability we getting chocolate on first trial, right? So chocolate on first trial. So we have a 3 chocolate out of 12, right? So 3 out of 12. Okay, then we have a chocolate on second trial with first chocolate, right? First trial chocolate. So let us do that. Chocolate on second trial with first chocolate. Okay, so what do you get? We had experience in the conditional probability, right? So this is dependent, right? Yeah. So we had how many chocolate left? 2 left. Out of how many? 11. Because the first one was chocolate, right? So 2 out of 11. Okay. What's the probability of chocolate on second trial? And first was not chocolate, right? Okay. So there will be, since the first one was not chocolate, there was the 3 still there, right? So 3 out of 11, right? Because first one was something else took out already, right? So this is we can think about now replacement, right? Yeah. You guys okay with this? All right. So X is not binomial random variable then, right? X is not binomial random variable. Okay, so let's take a look. Last question. X is the number of coin flips until you get tails for the first time. Okay, so what do you think? Is it fixed trial? No, because you might have n equal to 10, or you might have n equal to 100 experiment. Should not be 100 because tails is 50%, right? Okay, so the keyword is until, right? So you might get 6 times, or you might get 2 times, you might get 3 times, right? Until tails. All right. So no fixed number of trials. So it's not E, no fixed trial. So X is not binomial random variable. Okay. Okay, now we have another definition about the symbol. Okay, so we have n, so it's a fixed number of trial, and the capital X, the number of successes in the n trial, and P, we are using probability, right? Since section chapter 5. And in that case, the probability of success in binomial, right? So one trial. And then if we say that P equal to probability of success, then 1 minus P will be the failure, the probability of failure, right? So let me highlight. P is probability of success. Then 1 minus P will be probability of failure, right? Okay, so we have a notation. We will get probability of x equal to the number, then there will be exactly x successes. Yeah, so we're gonna get to this one later. All right. All right, so let's take a look binomial probability. This statement, I think we did that before, right? So assume that a student is going to take 4-question multiple choice quiz. Unfortunately, the student's browser is not working and the student is unable to read the question or options. So we randomly guess the answer to each question. Each multiple choice question has 5 possible answers. Yeah. Then what's the probability getting answer right? So answer right is a number of right divided by number of sample space, right? So 1 out of 5, right? Because 5 choices, 5 options, right? Okay, then 4 questions there, all right? Okay, so binomial experiment, let's take a look. So n equal to 4 because of 4 questions and fixed number trial. And 2 possible outcome, right or wrong, right? And what's the probability? It's 1 out of 5, which is 0.2. And is it independent? Yes, because the first question does not affect the second question of answer. Vice versa, right? Okay, so let's take a look this one. Tree diagram. It's a lot of work, so I'm gonna just take a look. So we have first is right, second is wrong. Then in the right, there's a right, wrong, right, wrong, right? And third question, in the right, right, wrong. In the right, sorry. In the right, hold on 1 second. In the right, right, wrong, right? In the wrong, right, wrong. In the right, the first one is wrong, second one is right, and right, wrong. And first one is wrong, second one is wrong. In there, right, wrong, right? Okay, finish. And we have a right, 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 and right, wrong. We have a right, right, wrong, right, wrong. We have a right, wrong, right, right, wrong. And we have a right, wrong, wrong, right, wrong, right? And wrong, right, 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 wrong, wrong, hold on, wrong, right, wrong, right, wrong. And wrong, wrong, right, right, wrong. The last one, wrong, 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 right, wrong. Whew. Okay, so everything, the result, right, 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 wrong, right, right, wrong, right. We have everything, yeah? And we talk about only the success. Success is get it right, right? So, right is the success. Okay? All right, so zero success is zero. No, not zero. Wrong, 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 wrong. Okay? All right, now uh, the probability, right? What's the wrong will be probability since we have 1 over 5 is right. So let's talk about that first because we knew already, right? So 1 over 5, right. First one is right, second one right, third one right, fourth one right. So it's a 4 time, right? Yeah, that's how they got it, right? Okay, so let's take a look. Right, 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 wrong. It's the same as a right, right, wrong, right? So basically we have a 3 success there. So 1 wrong, 3 right. Make sense? Okay, in that case, 1 over 5, which is right, to the third power. And then wrong will be 4 over 5 to the first power. Only one wrong, right? How many are there? 1, 2, 3, 4. So 4 of them. Yeah. So 4 of them of that. But in this one is multiplication. We not really have a bracket, right? So same as, yeah. Okay, now 2 is correct. So right, right, wrong, wrong, or right, wrong, right, wrong. Everything is the same, right? Just 2 right. 2 right means 1 over 5 to the second power, right, right? It's wrong, right? Yeah, right, wrong, right. Oops. Right, wrong. Okay, now I explained, right? So, okay, how many are there? 1, 2, 3, 4, 5, 6, 6 of them. That's how they got it 6. Okay, 1 correct. 1 is correct, everything's wrong, right? So this is right. This is wrong. So 1 correct, so first power from the 1 over 5. Wrong, then 4 over 5 to the third power, right? Okay. Now, how many are there? 1, 2, 3, 4. So 4 over there. Okay, none of them correct, x equal to 0, because right is success, right? Okay, wrong, 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 wrong. So 4 out of 5 is 4 power over 4, right? So we have 4 questions, and the right is a success. Yeah. So 4 questions. Right is success, and then 5 answers. 5 answers, 5 multiple choice answer. Multiple choices answers. Yeah. Okay. Uh, let me make a table. Oh, you cannot see. Okay. Let me make a table. Yeah, just take a look from the textbook. Yeah. So since I did not do at all, right? Okay, so earlier one, just make organize nicely, and then there is the probability in decimal, right? Yeah. Okay. Now, what's the main idea here? So look, we can see the X successes, then number of ways to get X successes, right? Like 4, 6, 4 in the case, right? And multiply by probability of successes. And the number of successes, how many, right? So 1 or 2 or 3, right? Yeah. Then we do times of probability of failure. So number of failure there too, right? So this formula from we can find out from the pattern, right? Then, oh, this is the same as this formula. Let's take a look. Okay, so this formula, which is from the combination. So combination, we have a number of trials factorial. So let me explain to you factorial later. And divided by number of successes factorial and times of number of failure. Okay. All right. So we want to understand the factorial first. We have m factorial, right? So the symbol is like that, m factorial. Yeah, this is like a exclamation mark, right? So exclamation mark, m factorial, but we read m factorial. We don't read exclamation mark, right? So we read m factorial. So like that, right? So we start m. Hold on 1 second. Let me make another page. All right. So m factorial means we started the n times and then reduce by 1 and then we multiply, right? And reduce by 1, we multiply until 1. So product of all positive integer less than or equal to the n, right? Okay, so let's understand that. So let's talk about 5 factorial then, right? So read 5 factorial. Okay, so we start the number first and then we make a product, right? So 5 times 4 times 3 times 2 times 1, right? Can you please calculate? 120, good. Okay, how about 4 factorial? So 4, start to 4 and 3 times 2 times 1, yeah. Yeah, it's 24, good. About 3 factorial, so start with the number first. So 3 times 2 times 1, so we have a 6. About 2 factorial, which is 2 times 1, which is 2. About 1 factorial, which is 1 times. Yeah. Start with that number with times 1, which is 1, right? How about 0 factorial? They say that 0 factorial is also 1, right? Okay, why? I can explain only like this. Yeah. Okay, why 0 factorial is 1? Let's go back. So we have 5 factorial, right? Can we can you express it as a 5 times 4 factorial? Do you think so? Yes, because we calculate we get the 120 as well, right? Okay, how about 4 factorial? Can we express this way? Yes, because we get the same answer, 24, right? How about we have a 3 factorial, which is 3 times 2 factorial. Can you do that? Yes, because we get the same answer, right? How about 2 factorial? Can you do that? 2 times 1 factorial? Yes, we get the same answer too, right? How about 1 factorial? It's 1. How about like a pattern? Can we express 1 times 0 factorial? I just follow the pattern, not the pattern, right? Okay. Yeah. But then what is this? This is 1, right? We knew that 1 factorial is the 1. Then 0 factorial must be 1, right? Since 1 factorial is 1, 0 factorial must be 1 as well. Is it clear to you? Yeah. Okay, very good. Now, combination. Yeah. So combination, we're going back combination. So we have a number of ways to choose X successes out of N trial. So this is a trial, sample size, sample space, and N successes, right? Choose X successes. Then we have M factorial divided by X factorial, M minus X factorial. Yeah? Okay. Let's just practice. So what if we have uh, n equal to 4? So we have a combination uh, for trial and we choose 2. So with combination, um, choose choose ooh, choose 2 out of 4 trial. Yeah, how about that? Or we can say the sample size for sample size. All right, then let's following the formula. So n factorial over x factorial and parentheses n minus x factorial, right? Okay, and in the case, this is a 4 and this is x, yeah? So there will be 4 factorial over x factorial n minus x, which is a 4 minus x factorial, right? Okay, let's calculate 4 factorial over 2 factorial. 4 minus 2 is a parenthesis. So we can calculate to simplify inside the parenthesis, which is 2 factorial. Okay, now we can say that this is 4 times 3 times 2 factorial, right? Over 2 factorial, 2 factorial. Okay, now simplify 2 factorial. 2 factorial over 2 factorial is 1, right? And we can simplify 2 factorial means just 2 times 1, which is same as 2, right? So 2 goes to 4 twice, right? And then 2 times 3, what do you get? Is 6. Yeah. Okay. Let me show you the decimals, how to use it, right? So 6, no, not 6, 4. We have to choose 2 out of 4, right? Okay. Um, let's do it. All right, so choose 2. So go to function and we have a, can you see the NCR, right? That's the combination. So looks like we put the M first, then R, right? So N in the car, sorry, uh, R is the same as X, right? Okay, N in the case of 4, go to main again, 4. Now we do comma, and then R in the case X, number of success, right? So which is 2, parentheses. It's a 6. We get the same 6, right? Same answer. Make sense? Very good. You don't have to do by hand. All right. We have binomial probability formula. Once again, the tree diagram is too much time consuming, right? That's a lot of work. We cannot draw every time for the probability, right? Okay, so they give us nice formula. Let's take a look. The symbol n equal to fixed number of trials, and p we are using the probability of success, right? And if we are using p as probability of success, then 1 minus p is probability of failure, right? Okay. Now x is number of successes, right? From the n trials. Okay. Now we have equal sign, that means exactly x will be number. It can be x equal to 1, 2, 3. Yeah, exactly. Then how many trials? That's the n. How many successes? That's the x. That's the x. That's the n minus 1, n minus x. Right? Okay. So this is basically the probability of success. Here is probability of failure, right? Remember we had uh, the earlier the pattern of the formula, and then they found a formula like that. Yeah. Okay. So let us do example here. At the time writing, approximately 70% of world population has been at least partially vaccinated against COVID-19. Assume that 10 people from around the world are randomly selected. Let X the number of who are at least partially vaccinated. Why this is a binomial experiment? Okay, so let's check that for criteria, right? Criteria. Okay, so binomial, is it n is a fixed number? Yes, n equal to 10, fixed number trial, fixed number trials. Okay, second one, what did we have? Fixed number trial. Uh, totally forgot. Success or failure, right? So what's the success in the case? Vaccinated? Yeah, so vaccinated is a success. Success. And then not vaccinated will be failure, right? Okay, what was the third one? Probability. So what's the probability? 70%, right? So number one, number two, number three, 70% is a probability. Vaccinated. Okay, how about number four? What was the number four? Independent, right? Is it independent? Okay, this is independent. We can say that why? Because n equal to 10, right? So we select the 10 randomly from the whole population. So it will be very tiny chance this outcome affect the other outcome, right? Make sense to you? Yeah, that is the key word. That is randomly, right? So that is independent. Also give us a step. So very, very tiny chance. There's yeah. How many population in the world? It's four, not four, 8 billions. Yeah, 8 billions, more than 8 billions. So we pick only 10, right? So it's impossible to have one outcome does affect the other outcome. Make sense to you? Okay. Okay, so I wrote down this one. All right, so let's take a look. The second one, find the probability that exactly 8 of 10 people are vaccinated, right? So what's the formula? Let's say using the formula here, right? So formula is 8 out of 10. Second part. Okay, so x equals 8 out of 10, right? So combination 8 out of 10. What's the probability? 0.7. And the success is 8. Success, right? Success is success. Okay. Uh, 1 minus p is 0.7. So whole thing is failure. Or we can say that a failure is, we knew that that is a failure. So we can say the 0.3. It's okay, we can do that too. So n minus 8. Now, I'm gonna show you how to use decimals. I showed you earlier, right? Yeah, so this is 0.3. And this is, this is 2, right? Yeah, okay. Uh, let me just using this. So 10 out of 8? No, 8 out of 10, right? That's how we say that, right? 8. Okay, now we make times and 0.7 to the what power? 8 power and times a failure 0.3 to the second power. Yeah, that's the answer. So 0.23347 So if we make 4 decimal places is 0.2335. Yeah. Okay, let's go there. So that will be 0.2335. Yeah. Okay. So let's take a look, see. So find probability that at least 8, at least 8. So what does mean at least 8? 8 or more until 10, right? So we had earlier the inequality symbol, right? I told you take a picture and then you can use during the homework and others, right? So at least means is greater than or equal to, right? So at least is greater than or equal to, right? So that is probability of x equal to, hold on 1 second, x is greater than or equal to 8. Yeah. Okay. So in that case, what do you have? Until 10, right? So 8, 9, 10. Make sense? Okay. So we had 8 previously, right? So we can find only 9 and 10, right? So 9 and 10. Okay, I need this one. How about that? Okay. Okay, so I wrote down this one. Uh, we have probability when x equal to 8, 0.2335 from B, right? Part B. Okay, how about 9, right? So let's working on 9 plus uh, the combination n equal to 10 and then 9.7 to the success is 9 and failure to the 10 minus 9, right? Okay, plus C combination 10, 10 and 0.7 to the 10 power and failure 10 minus 10. Yeah. Okay. So we have a combination. We have a choose 10 out of the same trial. Then we get the 1. Okay. This means basically think choose 10 out of 10, right? If we want to choose 10 out of 10, we have to take all, right? So only one way, right? So means take them all. So only one way. Yeah. Make sense? Or just for your reference, right? So for your information. So if we have a combination, 10 trials, 10 sample size, and then we choose 0, nothing, right? Then choose 0, none, out of 10, right? So out of 10 means take none. So only also one way. Yeah. So we have a 10. Choose 10 out of 10. There's only one way, so it's 1. And we have a 0. Choose out of 10 also. Take none, so there's only one way. Yeah. Okay. Now, can you please calculate? Give it to me, the answer. Okay, so what do you have? So 0.2335 equal to 8. And then the for x equal to 9.1211. Okay, thank you. And then the last one, we can calculate 0.7 to the 10 power because this one equal to 1, right? Any 0 power is 1, right? So we have 0.0282 then? 0.0282. Now, can you please calculate everything? So we have a 0.3828. So there is 38.28% chance that at least 8 out of 10 randomly selected individuals have been vaccinated against COVID-19. All right? Okay. The last one, I think, find the probability that fewer than 8, oh my gosh, fewer than. So it will be start to 0, x equal to 0, x equal to 1 until fewer than 8. So 7, 0 to 8. I'm sorry, 0 to 7. Yeah, because the fewer than 8, less than 8, right? Okay, let me write down. So fewer than different color. Fewer than, so x is less than 8. Yeah? Okay. What do you think? So D probability, right? So x equal to 0, 1, 7. Yeah, it's a lot of work. How do you do? Very good. We can use the complement rule, right? So complement rule. So that will be 1 minus opposite, right? Opposite. So what's the opposite? That will be, in that case, 1 minus the probability of x is greater than or equal to 8. Yeah. Aha. Then what is that? Earlier, we have greater than or equal to 8, which is that. Yeah. Ta-da-da. So easy, right? So that will be 1 minus 0.3828 from part C. Okay, now your turn. So 0.6172. Very good. Okay. Let me show you how to use a StatCrunch. Okay, so we have an example here. According to statistics, 62.5% of US are wireless only for voice service. Assume that 25 US households are randomly selected as that who are wireless only, right? Binomial. So let's check that the what is called the fixed number trial. N equal to 25, yes. And then success is the wireless only voice service, right? Failure not wireless only voice service, right? And third one, the probability is 62.5% for wireless only, right? And what is the number four? It's independent. Is it independent? Yes, it's independent because they said that randomly selected. Only 25 out of more than 8 billion, right? Okay, from now on, we can say that uh, it's independent. The sample of 25 is less than how much? 5%. Yeah, 5% of the total number of US households. So 5% of 8 billion is 400 million. So means that we have just a tiny sample from the 5% from the 8 billion, actually more than 8 billion for the world. Oh, no, it's the US. Hold on one second. US. So US population is 340 millions. So 5% of 340 million is 17 millions. So 25 is less than 5% of total number of US household. So we said independent. Make sense? So one outcome from the sample size 25, it's impossible to make a fact, right? Clear? Yeah. So we say that from now on. All right, so sample of 25 is less than 5% of the total US household. Okay, let's take a look the question. So I'm gonna show you stack crunch, right? 18 or more, so we can do that. 18 or more, so it's greater than or equal to 18 out of 25, right? And then at most is less than or equal to, so probability of at most 15, and between exclusive, oh, we don't have exclusive, huh? Oh, then how do you do? That's good. We don't have exclusive with between. Then we can use make inclusive. How? Think about that at first. 14 and 18 exclusive, but it's between. Okay, so this means, think about this. We have this creek, right? So it's a 14, 15, 16, 17, 18. The x is between 14 and 18, not include. So I want to put the parentheses, right? Then we want to make include with the discrete numbers. So it's better 15 and 16 and 17, right? So it's include, so I'm gonna put the bracket. Is it clear to you? So we don't put the 13, we don't put the 19, because it's between 14 and 18, but 14 and 18 is now included there, right? So this green number, it's better we have include with the 15 and 17. Okay, now E, between 15 and 20, inclusive, right? So this is exclusive, this is inclusive. So this is easy. We can just do x is between 15 and 20. Yeah. Okay, so would it be unusual if 20 or more household were wireless only? Yeah. Okay, so let me take a picture and then I'm gonna use a stack run and then we have finished this one. All right. Okay. Let me pause